And in order, we pass the tree, right? So which is, like in this case, we pass J in order mean left, right? So NQ the elements in the binary search tree in order, smallest to largest. Like in this case, the smallest is going to be B, left always smallest. So we're going to look at, we're going to traverse to the left, and then NQ itself. Like since we try to traverse to the left of B is no one is null, then reach the best case, which is null. It's not going to do anything, then it's just go back to NQ, right, NQB, and then traverse again to the right of Q. But it has to NQJ first, and so on. So let's look at the code here. So we're passing J in, right? Tree is not going to go, so we call in order again. So it's called self. So this is recursive. We call it self, and pass j.getLeft, which is b in, right? So call it self again. B in is do not know. We will do in order tree.getLeft. So b get left is null, right? So since it's null, tree not equals to null, it's going to do, then at that point it's reaching the best case, right? It's not going to do anything. Like if tree can do nothing, that's why we didn't have anything to do. We just do if and it's not null. Then it's not going to do anything, then it's going to go back to, let's close that and go back to the previous one, which is going to execute the next line of code in order q.enqueue. That's why I start to do enqueueB, right? p.getInfo, which is B. And then it's going to do so once B is in Q, then tree is J. So that's why J, right? B is getInfo. Now we go to B.getRight in order first. And B.getRight, that point is going to be null. That's why it's not going to do anything again. So it's done. Now go back to J. And when that J call is going to be the same J.getInfo. So that's why NQJ. J is NQ. And then j.getRight start to do recursively all the right now. And call getRight, which is passing Q in. So Q is here, which is not null. Then Q.getLeft passing L. Right, and getLeft again is null, that's why I start to NQL. Right, because L itself is null, not doing anything, go back and NQL. And then after NQL, so L.getRight is null, it's not going to do anything. Now we go back to the Q1, Q.getLeft. That's why we have L done. Then Q.getInfo and Q after L, right? So now Q and Q, and then Q.getRight, just pass the whole thing from the right of Q, right? Do the same thing again, which is recursively called R is here now, which is not equal to null. R.getLeft is null, do nothing, then NQR. Right, R.getInfo, then R.getRight, which is Z. Z is in, Z.getLeft is null, do nothing, then NQZ is done. Then Z.getRight is null, do nothing. So that's how we get in order BJLQ or Z. That's how we do in order. And the other two traversal is the same approach, right? But instead of this is what left root right, we're gonna change it. So let's look at the code. So we see how we implement in order, like left, root, right. So pre-order is what? Root, left, right. So we go into root first. And then just because we go to left and right. And last one is post order. Post order is left, right, root. So that's why we recursively go to left and right and then into root right there. Right. Because it's the same thing as we recursively call left when we want to get to into the left first. So we do into of the left. But this one we want to do root, so first root of right. Right. So this is just include the first one, right? Root and then left, right. So let's look at this example for post order. So we said we recursively, okay, first we pass p in, not known, and get the left is f, and get the right. But this is still open, right? It's called post order again. So let's get the left again, which is B, right? And then get the left of B is no, do nothing. Get the right of B is no, do nothing, and NQ B. So we get B first, right? And then when B is done, then we go back to F, right? Which is passing B in already. Then go to F dot get right, which is H in, and H call post order again. H dot get left, which is G, right? And G get left and G get right and no. So NQG. So that's why we have post of BG now. Let's go and do the same. H itself, right? Check get left past G already, then it's still get right, which is no, then NQH. So it's going to be BGH. So it's going to do like this recursively. Like you start to look, remember F past the right in now NQF. So BGHF. And then R, P, right? P, BGHF. P now also start finishing passing F in, then start to pass right in. So that's why right we get S, S pass left in, and recursive do it gets over and over. So that's why it's going to be left, right. So that's why we have to do left first, and right, and NQ root. So that's a post order. Right, left, right, root. And this is root, left, right. So that's what NQ root, right? Okay. Alright, so that's how we explain reset. We talked about that, right? So reset is the one is going to reset the order into in order, pre-order, or post order, which is going to call this method to use. And this method parameterizes in each order type is created instead of linked queue and bound queue. Like that's why we start to enqueue those into the list in order that we want. Now, testing the BST operations. The code for the entire BST call is included with the with the rest of the book files. We look at that one. It provides both the recursive size method and the accurate version of the size. We talk about that. We have also included an interactive test driver for the ADT called ITT by search tree. So it allows you to create, manipulate, and observe tree containing strings. So we talk about the book files here. You can just use this ITT binary search tree. Right. So this is just to test your BST here. Right, tree is empty, tree size, and the iterative version. So you can run this. It contains, remove, get, add, print tree in order, p order, and post order. Right, so in these cases. And to construct a tree, pretty much just create a tree, which is BST here, and use a string as parameterized type. This is just called the application, just the name, test name, value of the test case. So what operation that you want to use. So you can test this on your own by just copy a code and I think they pretty much gonna read in the data. So let's see how they read in the data here. First time when you create a tree is empty until you hit the add operation. It's gonna prompt you to add into the tree. So you construct the one tree. So we can look at this program together. So what I'm going to do, I'm going to just create a new package just to test this with the main code that we just looked at. So test new class ITT search tree. And we'll just decode that we want to test. First, we need to construct the binary search tree, which is in U2. I'm going to create that binary search. And we need both an interface and binary search tree itself. So let's create an interface too. So BST interface. I'll refactor it later into the format that I don't put I in front. I don't want to refactor